Welcome to the Chapter 8 Test Review Answer Key Explanation for Honors Geometry. So, as I go through this review, you'll notice that on these printed pages, it's mainly just going to be the answers over here on the right. And then following up the pages are the different written out explanations for the problems. So as I go through this, there may be more scrolling than normal just to make sure you see the work and the thought processes for the answers. So to begin with, going back to the top of the page, number 1 and number 2, they are fully based on these three images, A, B, and C. And for number 1, they want us to find the perimeters. Number 2, they want us to find the areas. So I'm going to scroll down and just work through 1 and 2, A, B, and C. So obviously I just redrew my diagrams, A, B, C here. Let's just focus on A, and we're going to take care of the perimeter and area at the same time. So looking at my figure, I know I have a parallelogram with a base of 11 and a height of 6. The other external side is 9. So let's start with finding perimeter. Perimeter is 2 times the 11 plus 2 times the 9. Adding up all of our exterior would give us 40 units. For the area of a parallelogram, we need base and height, so the two that meet at the 90 degrees. So our height's 6, base is 11. So our area would be 66 square units. Now moving on to figure B. We have a kite. In dealing with this kite, we know that the diagonals are perpendicular, leaving us a lot of right triangles. So we're going to use those right triangles to find our exterior, and one of them I labeled X, the other I labeled Y. I only need to find these two because if this one's Y, that one's Y, and if this one's X, that side's X. So first, let's find X and Y. So to find X, we're going to look at that upper right-hand triangle. We know it's a right triangle with a leg of 10 and a leg of 15. We're trying to find the hypotenuse of X. So 10 squared plus 15 squared equals X squared, which would give us 325 equaling X squared. So to undo the squaring, we square root each side. So X is the square root of 325, which we can simplify down to 5 square roots of 13, because the square root of 325 is the same as the square root of 25 times the square root of times the square root of 13, and the square root of 25 is where this 5 comes from. So we know X is 5 square roots of 13. Y, we're looking at this upper left right-hand triangle, or upper left right triangle. So we have legs of 7.5 and 10, trying to find the hypotenuse of Y. So 10 squared plus 7.5 squared equals Y squared. So we know 156.25 is Y squared. So Y is that 156.25 square rooted, which is 12.5. So now we know X and Y. So we can figure out the perimeter of our kite. We have two sides that are 5 square roots of 13 plus two sides that are 12.5. So that gives us 10 square roots of, and that should be a 13, not a 3. Apologies there. 10 square roots of 13 plus 25. So that would give us 10 square roots of 13 plus 25, which if we want to make that into a decimal, I'd take either answer, would be approximately 61.056 units. Then the area of a kite. Because the diagonals are perpendicular, we're going to use the formula for any quadrilateral with perpendicular diagonals. So our area is 1/2 multiplied by the length of diagonal 1 multiplied by the length of diagonal 2. So we know diagonal 1, when we added it up all the way across, was 22.5, and diagonal 2 was 20 units. So 1/2 times 22.5 times 20 gives us 225 square units. Now moving on to shape C, our regular hexagon. So they already gave us the apothem of 7 square roots of 3. So what I'm going to think about is drawing in a triangle from here to here and here to here that I can pull out. So we'll scroll down to see that. So if we think about pulling this triangular piece out of our hexagon, we knew the height of the triangle was 7 square roots of 3. And because it being a regular hexagon, this creates a 30, 60, 90 right triangle. So we know the longer leg is 7 square roots of 3. So to find x down here, it would be 7 square roots of 3 divided by the square root of 3. So I know x right here is simply 7. So the whole base of this triangle would be 2x, which is the side of our hexagon, because if this from here over here would be our measurement, we need to double it to get the whole side. So our whole side would be 2 times 7, which is 14. So now we can find the perimeter of that hexagon by doing our side length times the number of sides. So 14 multiplied by 6 gives me a perimeter of 84 units. Now the area of the regular hexagon. We'll be using the area of a regular polygon. So it's 1/2 multiplied by the length of the apothem multiplied by our perimeter measure. So 1/2 times 7 square roots of 3 times 84. So half of 84 times 7 is 294 square root of 3 units squared. And if we want to write that as a decimal, again, I'd take either answer. The decimal would be approximately 509.223 square units. So number 1 and number 2 are done, taking care of A, B, and C, these figures. Now moving on to number 3. Area of a rectangle that has one side measuring 10 centimeters and a diagonal measuring 26. So again, we're back to that idea of right triangles. So if I draw that rectangle, I have a side measure of 10, diagonal of 26. I need to find my other side measure, which is the leg of that right triangle. So we know 26 squared would equal 10 squared plus x squared. So 676 equals 100 plus x squared. So 576 equals x squared. And we square root that to figure out our other side is 24 units long. So now that we know this side's 24, this side's 10, finding the area of the rectangle is really easy. Length times width, or base times height, 10 times 24 is 240 centimeters squared, because in this case, they gave us the measurement instead of units. They told us it was centimeters. Now moving on to number 4. In 4, find the area of a circle whose circumference is 8 pi. So if we think about that, area of the circle is pi times radius squared. Circumference was 8 pi, so if I divide that by pi, I get my diameter. So my diameter was 8, meaning divide that by 2, and the radius of that circle was 4. Now that we have the radius, we can find the area. Area is pi times radius squared. So 4 squared is 16, so my area would be 16 pi units squared. Now moving on to number 5. Number 5, again, another circle problem. We know that the shaded region, sector, has 40-degree measurement, and it has a radius of r. So first, they want us, based on this info, and we also know, that it also has an area of pi. So this sector has an area of pi. So they want us to find the radius of the circle and the arc length of the sector. So first in 5, We're going to start off with understanding that the shaded region is 40 degrees out of 360 in the whole circle. So that means the shaded region makes up 1/9 of the circle, or 1/9 of the circle's area. So if the shaded area was pi, and that's 1/9 of my whole circle, I would need to multiply by 9 to get the circle area. So our circle area is simply 9 pi. And that's important to know because if we're working back to find the radius, we want that overall area. Because then we can think area equals pi times radius squared. So we know the area was 9 pi equals pi times r squared. So if we divide both sides by pi, we have 9 equals radius squared. Square root both sides, and we find out the radius is 3 units long. Then to figure out the arc length, what we care about then is the degree of our arc out of the 360, which we already established was 40 out of 360, or 1/9, times the circumference. So 2 times pi times our radius of 3. So 3 times 2 is 6, so that gives us 6 pi. 40 over 360 is 1/9. So 1/9 times 6 pi would be 6 pi over 9. We can simplify the 6 and 9 down to 2/3, so we'd have 2 pi over 3. Now 6 and 7, we're dealing with right triangle relationships. And in this case, they want us to find the missing length in each. So in A, we're looking for the hypotenuse. In B, we're looking for one of the legs. So if we think about Pythagoras' theorem, it tells us leg 1 squared plus leg 2 squared equals hypotenuse squared. So in 6, we'd have 11 squared plus 19 squared equals our hypotenuse x squared. 121 plus 361 equals x squared. So x squared is 482, meaning x is the square root of 482, which comes out to be approximately 21.954. Then in number 7, now we're looking for a leg. So we had used that, x squared plus the 6.5 squared equals our hypotenuse of 16.9 squared. So x squared plus 42.25 equals 285.61. Subtract the 42.25, and x squared is 243.36. So x would be the square root of 243.36. Divide, or not divide, put the square root into your calculator, and that comes out to be approximately 15.6. Now, as I mentioned, number 7 on the review and your test is extra credit, so I'm not going to go through that one. For 8A, they want us to come up with the values of x that would make this triangle a right triangle. So even though it's drawn this way, where it's not necessarily a right triangle, we need to do 2 different setups to find the value of x. One, if x is a leg, and the other, if x was our hypotenuse. So our 2 setups for that problem would be x squared plus 8 squared equals 19 squared, where we're trying to find our smallest value of x for the leg. And the other setup, 8 squared plus 19 squared equals x squared, where we're finding the largest possible value of x, the hypotenuse. So in the one where x is a leg, x squared plus 64 equals 361. So x squared is 297, meaning x is the square root of 297, which, as you can see, we can simplify to the square root of 9 times square root of 33, which means x is 3 square roots of 33. Or 8 squared plus 19 squared is x squared. So 425 is x squared, square root of that. Simplifies to square root 25 times square root of 17, meaning the other value of x is 5 square roots of 17. So then the range for the possible values of x going to that case, for A, it would be this or that. In part B, for this to be an acute triangle, x would have to be anything less than our hypotenuse measure, but greater than the smallest measure that makes it a right triangle. So x could be any value greater than 3 square roots of 33 and less than 5 square roots of 17 to make this an acute triangle. So now, going on down, past all the work here, on to our next page. Number 9. We know a square is a side length x centimeters. Kite has a diagonal x centimeters. Find the length of the other diagonal of the kite that will make it the same area as the square. So going down to the work for these, number 9, the square area is x squared. So the kite area, because if our square is a side of x, x times x is x squared. The kite area, we use that perpendicular diagonal for quadrilateral formula. So 1/2 times diagonal 1 times diagonal 2. We knew diagonal 1 was x, so for now I'm just going to call diagonal 2 y, what I'm trying to find out. So if x squared would equal 1/2 times diagonal 1 of x times diagonal 2 of y, then we would be able to divide both sides by x. That means x is 1/2 of y. So to get y alone, divide by the 1/2 or multiply by 2, meaning y would equal 2x, so that second diagonal's length would have to be 2x for the figures to have the same area. Now, in our next problem here, number 10, we're dealing with a rectangle inscribed in a circle O. They want us to find the area of this circle. We know the measurements of the rectangle, one side's 24, one's 18. So what we need to do with that image is we need to think about drawing in a diagonal. If it's TE or RC, doesn't matter. So if I drew in TE, I'm back to that right triangle where the hypotenuse is the length of TE, and my two legs are 24 and 18. So we can figure out that diagonal length by doing 18 squared plus 24 equals x squared. When we go through the math, that gives us 900 being x squared, so we know the length of TE was 30. So then, the radius of my circle is half of TE. So half of 30 would give me my radius, which gives us 15. Now, I don't care about the area of the rectangle, I just had that in there. We need to find the area of the circle, pi times radius squared. So pi times 15 squared, 15 squared is 225, so our exact answer would be 225 pi units squared. In 11, they give us 4 points to graph, and then 2 questions. Number 1, or 11a, is to name the figure. So after you graph it, you should be able to see that we have a trapezoid. Then for part B, the area of a trapezoid is 1/2 multiplied by the height multiplied by the sum of the two bases. So our base measurements, MN, would be 4, LO is 9, and if I draw in a height, it would give me a height of 5. So I have my measurements to come up with the area. So 1/2 times 5 multiplied by the sum of 4 plus 9. 4 plus 9 is 13, multiplied by 5, multiplied by a half, gives us the area of this trapezoid being 32.5 units squared. Now in number 12, they gave us the measurements of a rectangular plot with miles, and they want us to first find the area in square miles. So if it has a length east to west of 0.1 miles and a height north to south of 0.05 miles, we just have to multiply those two to get the area. So the area of the rectangle in square miles would be 0.005 square miles. Then in part B, they want us to tell how many acres that plot would be. So we need to take the 640 for our conversion and multiply it by our square mileage. So 0.005 times 640 would tell us that lot is 3.2 acres. Then going on to 13. 13 says the Nichols are installing new rain gutters along the edge of their roof. The rise of the roof is 10 feet, with the length over a length is 16 feet. To the nearest foot, how long will the rain gutter be for this portion? So if we think about that portion of the roof, we knew the rise was 10 feet and the run or the length was 16 feet. We're trying to figure out the hypotenuse in this case, x, the length of the gutter. So 10 squared plus 16 squared equals x squared. So 356 is x squared. So if we square root that, x is approximately 18.87, which means to the nearest foot, the gutter would have to be 19 feet long. And then 14, we're into another kite scenario. Pam's using 102 inches of ribbon to go around the edge of her kite. So we're thinking perimeter. Shorter side of the kite measured 15 inches. Find the measures of the other three sides. So they come out to be 15 inches, 36 inches, 36 inches. How do we know that? Well, we know in a kite, we have two sets of congruent sides that are consecutive. So if I drew my kite here sideways, and I knew this measurement was 15 inches, I also know this one, the next consecutive side, would be 15 inches. Then I label my other two sides X because they're the same. And I knew the total perimeter was 102. So if I'd take 102 minus the two sides of 15, I'm left with my other two sides that measure X. So 102 minus 30 would equal 2X. 72 is 2X, so we divide by 2, and each one of these other sides are 36 inches long. Now in 16, they're dealing with creating a circle around the edge of a flower garden with bricks. We used 114 bricks. If in part A, each brick is 8 inches long, what's the circumference of the garden? So we could just think of the 114 bricks times 8 to get the distance around the circumference. So 114 times 8 is 912 inches, or if we divide that into feet, convert it, that would be 76 feet. Now, the reason I cared about converting it to feet is it made it easier in part B, where they're asking the radius in the nearest foot. Let's go down and look at the work. So obviously, part A was just figuring out number of bricks times brick length gave us that perimeter. Now, the circumference is the same as perimeter. So if circumference is 2 times pi times the radius, and we knew the circumference was 76 feet, we can divide that by 2 pi to get our radius. So 76 divided by 2 pi, rounded to the nearest foot, means we'd have a radius of approximately 12 feet. Now we're on to the last page. So 17, 18, 19, 20. So with 17, it says, I'm assuming it's Cassia. That's what I'm going with. Cassia and Kelly are cutting out arrows to mark the route from their homecoming fun run. Each arrow is made up of a rectangle and an isosceles right triangle as shown at the right. So right here would be a right angle in this triangle. So first, in part A, if the given hypotenuse of the triangle is 30 centimeters, find the length of each leg. So let's go down and look at 17. So we know that this is an isosceles right triangle, meaning my two legs are the same. Isosceles right triangles are 45, 45, 90 special right triangles. So I know my 45 and 45 So we know we have a 45, 45, 90 triangle, hypotenuse of 30, and both side lengths are x. So using the 45, 45, 90 or isosceles right triangle rules, we know that the side length of x multiplied by the square root of 2 would give us our hypotenuse. So x times the square root of 2 is 30. So we're simply going to take 30 divided by the square root of 2 to get the length of each side. So our side length here would be 21.2 centimeters approximately. Then in part B, they want us to find the overall area of this arrow. So the arrow area would simply be the area of the rectangle plus the area of the triangle. So in that case, with number 17 over here on the left, we'd have 10 times 25 for the rectangle. So the area of the rectangle would be 250 square centimeters. Then for the triangle over here, area of the triangle is half the base times height. Because we have the right angle, our two legs are the base and height. So 1/2 at 21.2 times 21.2. So area of the triangle, 224.72. So to get the area of the arrow, we'd add the rectangle plus the triangle, which then rounded to the nearest square centimeter would be 475 square centimeters. Now, 18, we have a cooking scenario. Audrey is following a recipe for bar cookies that calls for a 9-inch by 13-inch pan. But she wants to make the cookies in a round pan so she can cut them into wedges instead of bars. So A, find the original area's recipe. So we're in a 9 by 13 pan. So 9 times 13 for the rectangle would tell us the original recipe calls for 117 square inches. So in B, they want us to find the radius of a circular pan that would provide the same area rounded to the nearest inch. So let's go down and look at B. So in that case, my area of the pan, area being covered, 117 inches squared. So we're going to use the area of a circle, pi times radius squared, to work backward to find the radius. So 117 would equal pi times x squared, our radius. So if we divide the 117 by pi, I would have 37.2422, whatever the rest of that decimal is, equaling x squared, square root, and the closest whole inch would be 6 inches. So the radius would have to be 6 inches. Then for part C, find the area of a cookie wedge if its central angle measure was 15 degrees, round that to the nearest square inch. So in that case, it'd be 15 degrees out of the 360. So if we do 15 divided by 360, multiplied by that overall area of 117, we'll get the area of that section, which comes out to 4.875. So that would be approximately 5 square inches. And then for 19 and 20, we'll look at the original document here. In 19, what we need to do is first find the perimeter of the figure. So I need to go in and find my missing side lengths. So the missing side length here is 3, because I know this is 3, that's 3, and if this is 3, that's 6. The missing piece would be 3. Now this missing height right here comes out to be 6, because I have 12 and 4 here, 18, and on this side 7, or 12, 12 and 4, 16. So on this side, 7 and 3 is 10, so I'm missing 6. So now to do the perimeter, I add up all the exterior, which you can see here, and the perimeter is 50 units. Now for the area, I'm going to cut it, as you can see by the orange dashes, into 3 different rectangles. Rectangle on the left here is 7 by 3. Rectangle up here is 4 by 3, and the long one in the middle would be 3 by 16. So 7 by 3 is 21, 4 by 3 is 12, 3 by 16 is 48. Add those together, and we get an area of 81 square units. And now down to the last question, 20. There's various answers, but this is my simple explanation for how we derive the area of or how to derive the formula for the area of a square from that of a rectangle. So we know the rectangle area was base times height. We know the side of a square can be called S. And if that's the side length, that's also the base and the height. So if we replace the B and H, each with S, the formula for area of a square, A would equal S times S, which A equals S squared. So we're simply, because the base and height of a rectangle are the same, they get replaced with the same variable, S, and S times S gives us S squared for that area formula. So I know this was a longer review, a lot of work to be shown, a lot of multiple steps. So if you have any questions in between now and your test, please make sure to come see me and I can help you out with understanding the different types of problems.